This is the brief on curvilinear coordinate systems, specifically hyperbolic and parabolic geometry. So we're going to look at how these two advanced coordinate systems, hyperbolic and parabolic, are built from the math up. And getting a feel for their unique geometry is so important because it completely changes how we do our calculations for physics and engineering in those spaces. First, you got to know that these systems go way beyond your standard x and y axes. They're built to tackle really complex problems in geometry. And to work with them, we need two key tools. One is the metric tensor. Think of it as a ruler for curved space. The other is the Christoffel symbols, which tell us exactly how the grid itself is bending and stretching from point to point. Second, the hyperbolic system is just incredibly dynamic. I mean, if you move along one direction, your local vectors start to twist and stretch like crazy. But then, move along the other direction, and the whole grid just expands, scaling up massively as you get further from the origin. And one of those Christoffel symbols we mentioned, it actually captures that exact scaling perfectly. And finally, a big mathematical goal here is to figure out if these systems are orthogonal. Do the axes meet at right angles? Once we get a handle on the geometry of the parabolic system, the real work begins. We have to derive these complex operators, things like the gradient, divergence, and curl, which are absolutely crucial for solving physics equations in these weird curvy spaces. Understanding these unique geometric rules is just essential for mapping complex phenomena when a simple grid isn't enough.